All right, I'm going to go through the Chapter 3 test review to get you ready for the test tomorrow. And we'll just go through the review question by question. First one is simplify secant theta minus tangent theta times 1 plus sine theta. To do these problems, I think it's usually easiest to get everything in terms of sine and cosine. So this is 1 over cosine theta minus sine over cosine times 1 plus sine theta. Then I can just simplify these fractions. And then go ahead and multiply 1 minus sine theta and times 1 plus sine theta is 1 minus sine squared theta. And that's all over, because remember this is just over 1. Multiply the denominators and the numerator. And this is cosine squared over cosine, which is cosine theta. And that's the answer to 1. Number 2, if tangent theta equals negative 3/4 on the interval 90 to 180, that's quadrant 2, find secant theta. Well, I'm just going to go ahead and draw my reference triangle. Tangent is 3 over negative 4, so this must be 5. Secant then is 1 over cosine. Cosine is adjacent over hypotenuse, so secant theta is negative 5/4. Next question. The amount of force needed to keep a stationary object on a flat surface from moving is called static friction. If a book weighs p pounds and it's on a flat surface that's at an angle of theta degrees, the coefficient of static friction C for the book is given by Cp cosine theta is equal to P sine theta. Solve the equation for C and find the value of C when theta is 45. So solve it for C. I'm just going to divide P sine theta by P cosine theta. P's cancel. This is just tangent. And it wants me to solve this when theta is 45 degrees, so I need tangent of 45. Well, tangent of 45, the legs of the triangle are identical. That's 1. Next problem. Simplify sine theta plus cosine theta times tangent theta. Again, I'm going to get everything in terms of sine and cosine. So this is sine theta plus cosine theta times sine theta over cosine theta. Cosines cancel. This is 2 sine theta. That's the answer for 4. Number 5, if 1 plus tangent squared over secant equals sine squared plus 1 plus secant squared, 1 over secant squared. Find cosine of x, plus pi. All right. So first thing I need to do is figure out what this angle x is. So I'm going to recognize that this is secant squared in the numerator. Secant squared over secant is just secant. And on the right, this is sine squared plus 1 over secant squared is cosine squared. So this is secant x equals 1. So where is secant x equal to 1? Well, secant x is the inverse of cosine. So we're really looking for where is cosine x equal to 1. Cosine x is equal to 1 when the angle is 0. So I know that this is when the angle is 0. So if I put 0 in here for x, 0 plus pi, they want me to evaluate cosine of pi. That's negative 1. That's my answer for 5. Number 6, the exact value of sine 285. There's lots of different angles we could split this up into. I used 150 and 135. And I used a sum formula. And that formula then, if I just use the sheet, is sine 150 cosine 135 plus cosine 150 sine 135. So I'm just going to draw both my triangles here. Cosine 150 is in the second quadrant, and this angle is 30. So that would be labeled this way. Sine 135 is also in the second quadrant. This is the 45 degrees. So that's 1 square root of 2. And this is negative 1. So sine 150 is 1/2. Cosine 135 is negative. I'm just going to go ahead and rationalize it. Square root of 2 over 2. Plus cosine 150 is negative square root of 3 over 2 times, and sine 135 is also the square root of 2 over 2. Positive this time. So just multiplying through, I get the negative square root of 2 over 4 minus square root of 6 over 4. So I could write this as negative square root of 2 minus the square root of 6 over 4. I could also just factor a negative out of the whole thing, and then it would be square root of 2 plus square root of 6 over 4. Either way, these are equivalent. Number 7. 7 says 2 wires support a utility pole and form angles theta and beta with the ground. Find the value of alpha, not beta, alpha minus beta, if cosine alpha is equal to 15 over 17 and in the first quadrant, and cotangent beta is 24 over 7, also in the first quadrant. So I'm going to go ahead and just draw my 2 triangles again. First quadrant, cosine is 15 over 17. And my missing side then, this is a 8, 15, 17 triangle. And that's alpha. Beta is, they say cotangent, so that's adjacent over opposite. And this becomes 25. So I've got my triangles labeled. Now I can just use a difference formula. So this ends up being sine alpha cosine beta minus cosine alpha sine beta. And I just plug in now. So sine alpha is 8/17. Cosine beta is 24/25. Minus cosine alpha is 15/17. Sine beta is, that way, 7/25. Just multiply through now. I'm going to have the same denominator. This becomes 192 over 425. And I'm subtracting 105 over 425 to get 87 over 425. And that's the answer to 7. Number 8, simplify, don't need to write that word, simplify cosine pi over 2 minus theta. Well, this is just an identity. Sine theta. Number 9, The horizontal distance x traveled by a soccer ball, if it's kicked from ground level with an initial velocity of v and angle theta, is x equals 1 over 32 v squared sine 2 theta. Find the distance traveled if the initial velocity is 45 feet per second and the angle is 30. Well, velocity is 45. The angle is 30, so 2 times 30 is 60, sine 60. And sine 60 is the square root of 3 over 2. So this is just a matter of plugging everything in the calculator, and you end up with 54.8 feet. Number 9, that was 9. Number 10. Find an expression equivalent to secant squared over tangent theta plus cotangent squared theta tangent theta. I'm going to go ahead and get everything in terms of sine and cosine. So I have 1 over cosine squared in the numerator. In the denominator, yeah, I'll just go ahead and do sine over cosine plus cosine squared over sine squared, that's cotangent, times sine over cosine. So this is going to cancel with one of these. This will cancel with one of these. So I have cosine sine in the denominator. So I'm going to leave 1 over cosine squared theta for now. My denominator is cosine sine, so I'm going to have sine squared plus cosine squared all over sine cosine. And if you recognize, when I take a fraction, I divide it by the fraction. It's the same as flipping. Or I can see that this denominator and this denominator, this will cancel with one of these. And then when I flip it, I'm going to have 1 over cosine theta in the numerator times sine theta over 1 in the denominator, which is just tangent theta. Another way I could have done this is factored out a tangent theta and had 1 plus cotangent squared and then used an identity there. Either way, you would have come up with tangent theta. If sine theta, this is number 11, is negative 4/5 on the interval pi to 3 pi over 2, which is the third quadrant, find the exact value of tangent 2 theta. So first thing, I'm just going to draw my triangle. Third quadrant, there's theta, sine, so this is the x value, negative 3. I use the equation for tangent 2 theta, which is 2 tangent theta over 1 minus tangent squared. And tangent theta is 4/3. So 2 times 4/3 over 1 minus 16/9, 4/3 squared. I need a common denominator here, and I'll go ahead and multiply through here. So I get 8/3 over 9 minus 16 over 9, which is 8/3 over negative 7/9. So if I go ahead and flip the denominator, I get, I could go ahead and cancel this with 3 of those, and I get negative 24/7. Number 12. If sine theta is 0.9, find 1 over sine of theta minus pi over 2. So sine theta is 0.9, which means, if I make it in fractions, 9 over 10. So this is the square root of 100 minus 81, 19. And if I think about it, if I know theta, this is theta, and I'm going to subtract 90 degrees, that means, let me draw this better. My triangle is not starting at the origin very well here. So this is theta. If I'm going to subtract pi over 2, that means this is 90, which means this is its complement. So this becomes theta, because this is 90. This becomes theta, which is, if I label this triangle now at 10, 9, 10, square root of, this one is the square root of 19. Recognize that this angle here is the complement of theta. So now, if I'm trying to find sine of theta minus pi over 2, it's this angle. And I want sine of the complement, so that becomes the square root of 19 over 10. Is that right? Yeah, this becomes, this is still 10. How am I doing this? This is not the same anymore. I'm totally messing this up and probably confusing you. I'm going to try this again. Okay. If this is my theta and my sine is this, if I'm going to go ahead and move it 90 degrees to the negative, it puts it here. This is now theta, so this becomes 9. This is 10. This is the square root of 19 for this new angle. That's this new angle here. So I want 1 over sine x. X is this angle. Sine of that is the square root of 19 over 10. So I want 1 over the square root of 19 over 10, which is 10 over the square root of 19. Sorry to confuse you there. Okay, moving on to 13. Solve 2 sine x plus 1 equals 0 on the interval 0 to 2 pi. So I'm going to subtract 1 and divide by 2. So sine x equals negative 1/2. I'm trying to figure out where sine x is negative first off, and that's going to be this quadrant and this quadrant. And what the angle is, well, for this to be negative 1/2, this is 30. So now I just have to get it in terms of radians. This is 180, or pi. 30 is pi over 6, so I want to make this 6 pi over 6. And add pi over 6, I get 7 pi over 6. That's this angle here. And this one, all the way around, in terms of a denominator of 6, is 12 pi over 6. I'm subtracting 1, pi over 6. So my other choice is 11 pi over 6. The refractive index of a gem helps account for its brilliance, as light passes through air and bends as it enters the gem. The refractive index of several gems is listed in the table. Find the approximate refraction angle theta sub 2, of a ruby when the angle of incidence is theta 1 equals 50 degrees using Snell's formula. Okay, and then they give us a table where N2 is the refractive index. So we just need to look on that table for ruby. N2 is 1.78. And we know theta 1 is 50. So sine theta 2, I'll put 2 here, times 1.78 equals sine 50. So sine theta 2 equals sine 50 over 1.78. So I just take the inverse sine of both sides, and I need the inverse sine of this whole thing. When you put all of that in the calculator, this is 14, you get theta 2 is 25.5 degrees. Next question. Solve 2 cosine x minus sine squared x plus 2 equals 0 for all values of x. So the first thing I've got to do is I've got to either get everything in terms of sine or everything in terms of cosine. And I can't really convert this to sine, but I can this. So I'm going to leave 2 cosine x the same, subtract 1 minus cosine squared, it's not theta here, it's x, plus 2. Go ahead and distribute my negative. Rearrange, so I've got my cosine squared first. 2 cosine x, and negative 1 plus 2 is 1. So this factors to cosine x plus 1 squared. And that means I'm looking for everywhere cosine x equals negative 1. I just set cosine x plus 1 equal to 0. Well, cosine x is negative 1 at pi, and every interval of pi, because it didn't give me a specific range of 0 to 2 pi, it just said anywhere cosine x is equal to negative 1. So to write that, it's going to be pi, and then it's going to be every time the unit circle circles back around to pi. So that's 2 pi times n. So if n is 0, then it's just pi. If n is 1, it's 3 pi. If n is 2, it's 5 pi, and so on. So as long as it's pi or some multiple of pi, cosine will be negative 1. So this is the answer here for that one. Number 16. Solve cosine x over 2 equals negative sine x on the interval 0 to 2 pi. Well, the formula is plus or minus the square root of 1 plus cosine x over 2 equals negative sine x. If I square both sides, I get 1 plus cosine x over 2 equals sine squared x. Multiply both by 2 sine squared x. I'm going to go ahead and get everything on one side. So I'm going to go ahead and subtract cosine x and 1, and then flip side. So I get 2 sine squared x minus cosine x minus 1 equals 0. Now I've got to get this in terms of cosine. So it's 2 times 1 minus cosine squared minus cosine x minus 1 equals 0. 2 minus 2 cosine squared minus cosine x minus 1 is 0. I'm going to go up here since I'm running out of space below. So I get negative 2 cosine squared x minus cosine x plus 1 equals 0. I always like to have a positive leading coefficient, so I'm going to just divide everything by negative 1. And now I could go ahead and let u equal cosine squared x just to help me make sense of this. I get 2u squared plus u minus 1 equals 0. So bottoms up, u plus 2, u minus 1, substitute back in what u is, and actually, sorry, u should be cosine x, not cosine squared. So this is cosine x plus 2 equals 0, cosine x minus 1 equals 0. So cosine x equals negative 2 Or, is that right? No, forgot a critical part of the bottoms up method, didn't I? I've got to divide this by 2. So this is u plus 1 cosine x plus 1. And cosine 2, well, I'll just do cosine x minus 1/2. So now I'm looking where cosine x equals -1 or positive 1/2. So cosine x is -1. Do that right? Yeah. Cosine x is -1 at pi. And it's equal to 1/2 at 60 degrees and 120 degrees. So that gives me pi over 3. And 120 is 2 pi over 3. Okay. Now, the one thing that the answers for this, pi was the only answer. And the only thing I can think of is when I plug in 2 pi over 3 or 5 pi over 3 here, I end up getting a positive square root of 3 over 2. And the sine of pi over 3 or 2 pi over 3 is, wait, cosine x is negative, yeah, is square root of 3 over 2, and then this becomes negative. So I don't think you can have the square root of a number be negative. However, this plus or minus here would allow me to have either plus or minus the square root of 3 over 2. So I personally think that these two also work. So I would accept either pi or all three of those. Okay, Mach number. The angle theta at the vertex of the cone-shaped shock wave produced by a plane breaking the sound barrier is related to the Mach number m, describing the plane's speed by the equation 1 over sine of theta over 2 equals m. It just wants us to solve for cosine theta. So we don't have to solve for theta, we just want to get it down to cosine theta. And this is number 17. So sine theta over 2 is 1 over plus or minus the square root of 1 minus cosine theta all over 2. If I square both sides, and I know m is equal to 1, that's what they tell me. Actually, I'm going to go ahead and multiply the denominator, both sides. So I get 1 equals the square root of 1 minus cosine theta over 2, just to flip this over. Now if I square both sides, I still get 1 equals 1 minus cosine theta over 2. Solve or cross multiply to get 1 minus cosine theta equals 2. Subtract 1, I get negative cosine theta equals 1. So cosine theta, which is what I'm looking for, is equal to -1. Number 18. Find the exact value of negative sine 75 degrees. Well, I'm going to do a half angle here. This is -5 of 150 over 2. And the half angle then is negative 1 minus cosine 150 over 2. I do a quick triangle reference angle. Cosine of 150 is here, and it's 30 degrees. Cosine's negative square root of 3 over 2, so I have 1 minus negative square root of 3 over 2 over 2, and it's the square root of this whole thing with a negative in front. So this is equal to negative 2 plus the square root of 3 all over 4, which is negative the square root of 2 plus the square root of 3 all over 2. And that's the answer. (19) Rewrite sine 12 theta sine 9 theta as a sum or difference. So I'm going to use the formula on the formula sheet for when I have sine and sine of two different angles. And it's 1/2 cosine u minus v is 3 theta minus cosine u plus v is 21 theta. And that's it. Just wanted me to rewrite it. Number 20. Find the exact value of 1/2 cosine 15 degrees sine 315. I'm going to use a product to sum here and get 1/2 on the outside. This is my cosine u sine v, so we can use the product to sum formula on the formula sheet. And that formula gives us 1/2 sine of u plus v, which is 330, minus sine of u minus v. U minus v is negative 300. So now I've got to figure out what sine of both of these angles are. Sine of 330 is right here, or this is 30 degrees. This is negative 1, 2, square root of 3. So sine of 330 is negative 1/2. Sine of negative 300, I go the other way, and I stop here. This angle is 60. So this is the square root of 3, 2, 1. So this is minus sine, or not sine, sorry, is square root of 3 over 2. All times 1/4. Just 1/2 times 1/2. So I have 1/4 times negative 1 minus the square root of 3 all over 2, which is negative 1 minus the square root of 3 all over 8. I could also pull a negative out and have it be 1 plus the square root of 3 over 8. So these are identical. Okay, bonus. Find sine of 4 theta if theta is on the interval 180 to 270, so that puts us in the third quadrant, and cosine theta is negative 4/5. So quickly I'll just draw my triangle in the third quadrant. This is negative 4, 5, negative 3. Sine of 4 theta, I'm going to use double angle formula. So I'm going to find it here, which is sine of 2u. I'm going to let u equal 2 theta, because if I take 2 times 2 theta, I get 4 theta. So this 2u is going to be 4 theta. That's equal to 2 sine u cosine u. Just using the formula sheet for the sine of 2u. Now I'm going to replace and now I've got to do it again because I'm trying to get down to theta. That's what I have here. So I'm going to have to use that formula again. So I have 2, this 2, times 2 sine u cosine u. Actually, now I've got theta. Times cosine 2 theta, I can choose a couple of formulas. I just picked one. 1 minus 2 sine squared theta. So this gives me 4 sine theta cosine theta times 1 minus 2 sine squared theta. I could go ahead and FOIL everything or distribute, but I think at this point I know what sine and cosine of theta are from this triangle, so I'm just going to fill it in at this point. I think it'll be simpler to multiply these once I have it with numbers. So sine theta is negative 4/5. Cosine theta, or sorry, 3/5. Cosine theta is negative 4/5. And then I have 1 minus 2 sine squared theta. Well, if sine theta is negative 3/5, 2 sine squared theta is 9/25. So go ahead and distribute these through. I get 12 times 4 is 48 over 25. And here, this simplifies to 1 minus 18 over 25. So if I want a common denominator, it's 25 minus 18 over 25, which is 7 over 25. And 48 times 7 is 336. And 25 times 25 is 625. So that is the answer to the bonus. Okay, that is it for the review. Tests will be tomorrow. It will not be a work with your partner test. It will be a test, though, that you're able to use the formula sheet.